Introduction. In the last decade, interferometric synthetic aperture radar, in SAR, has widely spread for measuring ground deformations caused by disasters, for example, earthquakes, volcanic eruptions, or subsidence. It can measure several centimeters of deformation with one pair of SAR images. The accuracy can be increased to several millimeters per year by applying time series analysis. Compared with traditional optical or amplitude-based SAR analyses, for example, the advantages of an SAR-based monitoring are, for example, its sensitivity for the deformation and all-weather availability. It is effective in the detection of various deformations caused by disasters such as earthquakes, volcanic eruptions, storms, and human disaster. Especially for the long wavelength SAR, i.e., L-band SAR, its long-lasting temporal coherence enables us to perform precise multitemporal interferometric coherence analysis. Polarimetric analysis, PolSAR, has been also proposed for the damage detection using scattering mechanism analysis. In PolSAR mode, SAR transmits both horizontal and vertical polarized waves and receives their co- and cross-polarized signals to see the scattering mechanism of targets. The collapsed buildings show different scattering mechanisms when they are compared with standing buildings. The most important examples are derived from 2011 off the Pacific coast of Tohoku Earthquake. Current problem for this method in the operational SARs is that there is less acquisition for full polarimetric mode, narrower swath width, and less spatial resolution caused by the operational limit of the platforms. Another merit of spaceborne observations is that they have a wider observation swath than that of airborne observations, resulting in faster measurement over a wide area. However, the area of deformation is assumed to be larger than hundreds of meters in the world of an SAR. If its spatial resolution increases, it can be applied to smaller targets' deformation, for example, the disaster monitoring of harbor facilities smaller than 100 meters, in addition to the existing change detection methods, for example. Currently, operational SAR satellites aim wide swath or high resolution. ALICE 2, Cosmos SkyMed, radars at 2, and Terra SAR/10DEMX aim higher resolution, represents the ensemble average of the samples in less than greater than. In short, gamma is a normalized cross-correlation of MANDA-S, and thus, it varies from 0 to 1. Gamma equals 1 only happens when m equals sand. Gamma equals 0 never occurs because of randomness. A large facility has a relatively high, approximately 0.7 to 0.9, value. Contrarily, bare soil and concrete caisson have low, 0.3 represents the ensemble average of the samples in less than greater than. In short, gamma is a normalized cross-correlation of MAND-S, and thus, it varies from 0 to 1. Gamma equals 1 only happens when m equals sand. Gamma equals 0 never occurs because of randomness. A large facility has a relatively high, approximately 0.7 to 0.9, value. Contrarily, bare soil and concrete caisson have low, 0.3.